Okay, let's get started. So yesterday, we were doing our animation state for our character, yet when we initiate a change, we get the right position eventually, but our character kind of goes off screen. And if you think about it, you know, since the player has to move from here to here by the time we initiate that transition, it does. But if you imagine him scrolling on this very frame and this frame scrolling off at the same time, that's why he's moving like double as fast. So I think I know how to fix that. We'll see. We'll see if we can figure it out here. So what we're gonna do is just take a look at where we are doing the render for our player. So maybe we can, and we should know this. We should know this. We're in our scene and we're rendering it. Okay. So I think this is the problem. We're rendering our player in our scene, and our scene is what's getting translated. So effectively, our player is getting translated off screen when we initiate that. We're at 60 FPS now, but we look frozen. Let's see. Okay. So I think what we have to do here is make sure that we're not translating our character and we only translate our scene. So let's see if we can't give that a try. And we'll do a love.graphics.push to only translate these values, and then love.graphics. I think this is the order. Push and then pop. And our player render is outside of the pop, so I think that means that we'll not shift our player off screen. Let's see. Nice. Yeah. Okay, so we're able to change directions here while we're moving, which I don't think we should be doing that. Oh, we got blurry face back. Last time we kind of figured out that if we are rendering not at a perfect pixel, it'll kind of interpolate, and that's what the blurry is getting. Now we do floor our position normally when we're walking, but for some reason I think when we tween our value, it just interpolates into a decimal point. So let's handle that. We'll go into our entity, actually our player, I think it's in our scene actually, our tweening values for our scene. And we'll go, we want to find where we're doing the translations, the tweening values. So if we do a grep string for tween, we can find our tween. Huh. It's not here. I think it is in our, yeah, right here. Oh, it's a lowercase t. I thought grep was a case insensitive search, but maybe not. What we'll do here is we'll floor the value that we're tweening to. So by the time we end up where we're going, we'll math floor that value, so we hopefully don't have those issues. Okay, now let's see if we've got we should have nice round numbers, just like that 0.0 whenever we stop. Upon a transition like that, yeah, it should stop. Cool. So it looks like we've got those nice values. Now I think we want to not update our character while we're going like this. Hey, aka Bob, what's up, dude? So yeah, I think we'll want to not update our player once we're in a transition. So we can get around to that. I do want to look up. I think it'd be kind of fun to do to test a new entity today. Let me see if we can find a reference video for a gecko walking. Let's see here. Look a little crusty. Oh, it looks just like Jimmy. Probably as jumpy as Jimmy too. Okay, this isn't really gonna help. Oh, here we go. Yes. Yes, something like this. So like if we draw a little gecko like this, and then, hey, nice man. Yeah, right under the 10-minute mark. Yeah, Jimmy gets a little crazy. There we go. So yeah, it looks like... That's exactly what they do, is they just freaking leap. I'm looking for like the footsteps, you know, like how it takes footsteps. So something... Wow, it is just, it's not easy to get a good... Yeah, you know, Jimmy still's got his tail. He sleeps... Oh, there we go, there we go. That's the reference we're looking for. Right here. Jimmy sleeps like upside down, so his tail will fall over. So when he's like walking around normal, his tail's got a big old crick in it. Which I guess he doesn't care because he still sleeps upside down and it still is just cricked up. That's exactly what we want. And even the tongue is perfect. So I wonder if we can do like... Yeah, you know, well, especially because Jimmy is so jumpy. They normally lose their tail like around year 1 or so. Most of them end up losing their tail, but Jimmy, for some reason, still got it. Yes, just like that. Yes. So it's kind of like it's like a left hand, right foot, right hand, left foot. So it's like the hand is first, then the opposite foot, then the other hand, then the other foot, and then we can add the tongue. That's going to be perfect. So if we can get a couple frames like that, maybe, you know, 5 or 6 frames, then we can start adding little gecko entities into our desert or whatever, which I think would be really fun. So what we can do here is we can kind of screenshot, you know, if that's frame 1 with his left foot up, let's just take a screenshot here. That worked out perfect. Then we'll hand up. That's like frame 2 before that foot comes up. And then that foot comes up, that's the next frame. And then right hand, that's the next frame. And then left foot, that's the next frame, and that's the start frame too, so that might be where we add in the tongue. So let's see if we can pull up those screenshots here. Pop, pop, pop. Where did they go? Here we go. Okay, so we've got... Cool. So this is kind of like an idea for it, right? So if it starts and ends with the left foot up, right hand out, it goes left foot, or it goes hand first, so the hand moves first. So this is like the start position. Left hand is that first animated frame, then right foot. Then right hand, left foot. And then tongue will probably be this first one. So we might get away with five frames here. Cool. So maybe we can pull in this one. What is this one? The 07. We can pull this one in as a reference. We know it's called 07 in our screenshots. So let's go into Aseprite here. Let's see if we can open up our screenshots 07. Okay. 07 from today. That's going to be the one. Yep. Cool. Now, our tile sizes are 16 by 16, but that's too big for a gecko. So we'll see if we can make 8 by 8 work, but there's probably too few pixels. Oh yeah, oh god. Maybe they're just gonna be 16 by 16 geckos. Because if we wanted to draw a gecko, you know, like hand out like this, it would look something like this. Not very readable as a gecko, right? At an 8 by 8. I mean, 16 by 16 isn't going to be much better either. Let's see. And what we can do is we can pull from our reference here, and we can say, we'll probably make the gecko have a frog butt without tail, because it'll allow us to put more detail in the picture here. But if we put this gecko in a 16 by 16 window here, let's get this bigger. Yeah, we'll see how oh god. We'll see how readable this size of gecko might be. Okay. I know there's a better way to do this. Let's... Oh, look at that. Looks like a starfish. Okay. Now... It's not so readable, is it? I mean, that's actually not too bad. It doesn't have the tail, but our game is so tiny, we can't make a gecko look good in 16 by 16, so we kind of have to make do with what we can. And we can't do the tongue like we were wanting to, because there's just, you know, the tongue would be 1 pixel, and that it's just not readable. So that's the general shape of a gecko in 16 by 16. So what we'll do is we'll try to just make it work. We'll have that as a reference, and we'll try to draw 1 frame of him and then see how that goes. So if that's our layer 1, we want a new layer. And our new layer here will be on top of this layer, and we will first draw an outline. Let's just do it in black. of what the outline of our gecko might look like. So we've got a nice spade head. Looks like poop. His head looks like poop. Okay, and then we've got. I'm mature. We've got his little hand. Okay, and then this is like the first animation frame. So like this would be right hand up, and then the next one becomes. And I kind of like the U's as his hands because it's kind of readable there. But we'll see. We kind of want his body to be not too thick. And we don't want it to be blocky either, so let's see if we can make another little U for his foot. Oh god. And then he's got a little foot here. Okay, so let's see how this looks without the reference behind it. You know, we would probably want to give him a little frog butt. It's so tough with only one pixel to work with. I think what I want to do is give him a little frog butt like that, but then move his foot here up just a bit. Yeah. Okay. So if we color this appropriately with some good colors, it might be readable. And if we shade it, you know, decent. I'm gonna pull up that reference of our Cresty here in the back so we can kind of see the color pattern. So let's just put that right here. Okay, so if we give him the nice dark brown, we know we want the little stripe here down the middle and into his head. So we'll give him the stripe. And then he's got the stripe kind of going out to his arms too. So we'll kind of make like the top ridge of his arms get the stripe maybe. And then the top edge of his feet maybe also get the stripe. But not his feet itself. Let me see. That's not quite looking like I want it. I think we need to go simpler with the stripe here. And maybe the move is we just have those highlights on his I don't know. Is that too weird? We give him one frog butt like this, like 1 pixel of frog butt. Maybe. Or should we give him a big booty like that? Yeah, that's good. Like a little pointy butt. Oh, this is gonna be cool. Okay, I'm starting to see the vision. I'm starting to see it. Now we can do a little eyeball too. So his eyeballs are like right here. Yeah. Oh, that looks pretty good actually. That's cute. Yeah, I like the booty too. We'll keep the booty. And then his left foot might need to go 1 pixel out like this one is. But that's looking good. Looks like Jimmy too. Yeah, I think it needs to come out like that. And then that looks good. That looks good. Now the question is, should we keep a highlight on his back foot here or just simple it down into that? I think that's okay. Now I'm kind of curious, like how his booty move when he walk. Like, do we scoot his booty? I feel like when he reaches with his right, his booty should be like 1 pixel to the left, and then when he's left, his booty's to the other way maybe. But we'll see when we animate it. So what we can do here is add a new frame, and we can say, how do we add a frame, new frame here? Okay, so this new frame, what we can do is, the order of operations was right hand, then left foot, and at the same time his right hand kind of comes. Actually, he doesn't come back. Let's see, because I think all we gotta do is scoot his. We delete this so that we can scoot his left paw, his left. What are gecko hands called? Pizzas. Okay, and then I think you know, this paw needs to come back. Yeah, it's not a paw. It's not a paw. I think I'm gonna go with feetses. Not feces. Feetses. Oh, and you know what? His hand kind of stays up. Well, actually, yeah, I think his hand actually stays up. So we'll get right hand, left foot, left hand, left foot. So I think his right foot needs to go back at this point. Back, by back I mean down. And then that's pretty good. So look, if we animate this, his feet move. Now we should try to make it similar to this. So what we can actually do is we'll take his left foot here, and for his right foot, it'll get a copy of his left foot just in the same kind of location, but we need to move. How do we, before we paste it, we need to erase its foot here. Let's erase this foot. Go back to frame 1. Copy his down foot shape. And then on frame 2, we give him his down foot shape on this side. Yeah. And then we'll get, I feel like maybe we delete a pixel right here. Little scurry guy. We'll continue and we'll go. So if it's right foot, then left foot steps, then the next frame is left paw goes up and his right paw would come back. It's not a paw. It's not a paw. Okay. So I think what we'll do is we'll just try to mimic his upward paw right here. And then give his right on that, and then okay. and then we'll scoot his right paw back to be hopefully what his first paw was, which was just a U and a square. So like it's really just like a U and then a bigger square to kind of hold it. Let's see. Actually, that's really cute. It's not quite there. It's close though, because like what's the if we frame it one by one, it should be, yeah, we should wait. So it should be, if this is his right paw's up, we go left paw up, right paw not down just yet. Then the next frame should be right paw down and not left paw up. And then it should be left paw up and then back to. So I think what we need to do is keep his right foot up for this frame 2. And then we'll delete this pixel here too. So all this is left foot up, and then it's left foot up, and then left hand up, and we'll keep. Yeah, so what we'll do is we'll add a frame right here, and this is right paw up, left paw up, left back paw up, then it's left paw forward. Let's see. Oopsie. Yep. Okay. He looks like a lobster there almost. So yeah, it should be like left, right, and maybe his down paw should go down there too. It's hard to imagine what the good movement is. And it's so much work just to get one frame on that it's like. You gotta really work for it. Okay. So down, down, down. And then now it's not quite the right movement, right? Like, and first of all, this pixel should be deleted. It should look alternating, and it doesn't look alternating. Like, it looks kind of. Let's see our reference again. So now if we kind of normalize to his head position, then right. Yeah, his right does go backwards because he's crawling. So anytime his right paw goes up, the next frame should be lower. And then anytime his left paw goes up, the next frame it should be lower, because that's how he's crawling. So we're missing this aspect where if you look at his left paw, it starts at his head, goes lower beneath his head, and then his right paw goes, his bottom foot paw goes from his tail to like lower. So that's what we're missing. So let's see if we can't get that. So anytime his foot is up, the next frame they need to be lower because he's crawling. So If this is frame 1, and let's just start again. Let's start again, new frame. Let me just honestly just delete these real quick. So frame 1's here. Frame 2, we need his right paw to be moved down. But not all the way, because he needs it to move again before it moves up. So and then this his bottom, let's see. It's really hard to envision this. Okay, I think we need, if the next kind of keyframe is left bottom paw up, we need to get that one up halfway and then lower his other one by halfway. That's looking more right, I think, because then on the next frame, his left paw is up halfway. And that would mean his footsie is all the way up. Which might be here. That looks jacked. So, and then his right, this one would be lower. Okay. Now I think his left foot looks jacked for sure. His bottom left foot here looks way jacked. It should be, I think it shouldn't be so far out to start with. That looks better. And then kind of shape it better. Yeah, I really don't like this frame of it. It's like not right at all. That's looking better. So, bing, bang, boom. Yes, that's looking better. Now I think we need this frame back here. It really does look like Jimmy. Okay. So, left paw goes up. Now, it needs to meet halfway here. So on this frame 2, left paw will go up 1. So, bing, bang, boom. And then his left paw. Let's see. Yeah, so starts up. Okay, so this frame, his hand needs to be midway. Okay. Yes. That's getting close. Now I think this can afford to scoot left 1. Well, that kind of looks weird. Yeah, I like it better where it was. It's not quite... It doesn't look like it's got the same crawl motion. Like, we're missing out on some key. I mean, it's only 3 frames. We said we would do 5, so like if it's first hand there, then yeah. And you know what? I think if the opposite, you know, right hand and left foot are moving and meeting, the hands that are about to move don't shift, they just reach. So like we would skip. I guess what I'm saying is like this one wouldn't shift his foot down. His foot would remain unchanged, and same with his other hand. His other hand would remain up here, actually down here for this one, and it gives a more, it'll give a more reaching feel by the time he reaches with the next frame. So it's like those two fall, and then this is the reach. Yeah, that looks better. So like boom, boom. And then I think I want to copy this shape and put it right here because it'll look better. So let's just flip this. Okay. Okay, we're losing it somewhere. I think those two are fine. I feel like we shouldn't have 3 frames of adjustment for the feet. I think no, yeah, I think 3 frames. There are 3 pixels of adjustment is good, but we need to adjust the timing of it so that it looks, and maybe we do. They kind of like, let's watch the reference video again and see. And of course I closed it. Let me try to pull up the reference video real quick. I shouldn't have closed it. Did I really close it? No, I didn't. Okay. So reach, and then it kind of pauses. Oh, it's so cute. Yeah, like if we were gonna double up on any frames, it's the ones right after it gets planted. Because the swoop is blurry, right? The swoop when he reaches is blurry, so we kind of want to like double up on the reaching frames. So maybe the second frame here is only a 1 pixel adjustment for his hand. So boom, 1 pixel adjustment, and then they go to where they live before they reach again. Let's see. It's just really tough. I didn't think I'd be animating this all day. I was thinking we would just get, I'm liking it though. I'm liking it. Like, what doesn't look right about it? Maybe this pixel here. Okay, so this reach definitely looks wrong because of that pixel. That looks better. Yes, that looks better. Now I don't like that this one shifts inwards. We'll see what that looks like. That does look pretty good. I think it can afford to reach 1 higher. Yeah, because this one goes one above his diamond head, so this should also go one above his diamond head right there. Okay, and I think we need to level these out with his head there. Well, actually, that would be level, so his first frame would have a brown pixel right here. Okay, that's looking oh, that's looking really good actually. That's it. Like that's the starting frame, right? Like that looks really good. And then reach. Reach. I feel like his reach, maybe this one can come in. Bah. Looks weird. That left foot looks weird coming in. So maybe it just goes one higher frame like we had it. But how, okay, so how does we need this shape for the third, yeah, we need this shape for the third frame of our left foot. So we need to delete this. We need to add in that shape, but reversed. Right here. Okay. So up and reach. That's looking good. So then the next step is to shift his right paw down one. Looks like this can afford to be 1 pixel left, maybe. I feel like his body isn't completely centered, so it's throwing us off just a bit. Because if we draw, like, let's say, it's 8 by 16, so 1, 2, 3, 4, 5, 6, 7, 8. So these two are the middle, but his head comes to a point, so we can't have his head perfectly centered unless we waggle his head a bit, which actually probably we should do. Let's see how his head moves as he's walking. It does. So when he reaches with his left, his head goes right just a bit. So I think we can afford to scoot his head a little bit to the right upon the reach. No, it already is to the right. So what we need is, on here, we need to move it to the left. And that makes it look all jacked up. Actually, doesn't look all that bad. So what we'll do is, we'll fix our nasty pixels here. That looks good. See, but then I really liked that first frame of him. It looked so good. And now it doesn't look as good. So I'm thinking maybe we start there. Well, yeah, if his head moves to the right, when his left hand's up, his head would move to the left when his right hand's up. So let's go ahead and just shift all of this over by 1. Yeah. And then like he's got a little crook in him, but Jimmy's got a little crook in him, you know? I don't know if I like his stripe being cut like that, but if we only do it, yeah, the stripe being cut looks really weird. So maybe we keep We keep the stripe as is, but we move his head itself. So we'll keep the stripe. That'll just add some continuity. Yeah. Oh, that's looking close. That's looking good. It does look hella empty right here, so maybe we'll fill in. Yeah, fill in that. His hand looks so stretched in this one. His hand, okay, so his hand should be... Okay, so I think what's missing here is that he's got a wider head right here that he was missing. That's looking close. That's looking really close. Now, I think right now his head is only shifted. We've only got 3 frames, so let's make sure we've got 4 frames. So if hands up, his left foot comes up. So left or right hand up, left hand up. And then we need another frame. But before we copy that, we need to make sure yeah, it looks like there's 2 pixels from the top, 2 pixels from the top. And then it only moves to the left, or only moves back to the right once his hand is fully up. So we'll shift his head to the left here, and that will hopefully make it look better. So where did that come from? Okay. The shape of his head is getting jacked. So I think we do want the long head here. Yeah, I think we do want that. But this should be his left paw going down. Yeah. It's not there. It's getting close. Okay, so I think his left paw here should not move. Let's see. He does look like he's dancing. This is getting close. And then what if we duplicate this frame, if we copy this frame and put it on a new frame, can we just copy and paste? Okay, it's not quite there because reach. Oh. Dump, 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 dump. Okay. Okay, we're really close. So I think if we just add a new frame, and if we take a look, like his opposing far paws come in by 1 pixel. So we'll take his opposing far paws and bring him in by 1 pixel, and then the next frame will be the reach, and then it might look good. That's close. That's close. Dude, so my stream is like, it'll go from 50 FPS down to like 13 sometimes. But I don't know. This is looking close. Trying to think of what would make it look better. Now his head is slightly not symmetrical, like his orange should come out to here every frame to kind of center that diamond head. So that might help a bit. Actually, yeah, that looks pretty good, but I think his inward feet, when his feet are closest into him, I think they need to be even higher up. Because look at how high up he brings up his left foot, like to the bottom of his other paw. So when he brings his foot up, it goes up, almost touching that down paw. So by the time, yeah, this isn't right, because his, yeah, see, because if we go from, let's go, this is our matching kind of thing. That looks pretty close to that reference. And then the next frame should be his left paw comes up to meet this one. And that's not happening. So let's see what that looks like. So we'll move his paw up close to meet that other one. We'll just put this paw down. And this might not, we don't want this to be too big of a movement. But that looks more like the reference photo than it was. It's still like, they need to like touch basically. So I think we need to add one more frame here. It is looking close, but it should go after he steps with his right, his left 2 paws come to meet. Well, step. See, like, look at that jump. Basically, the only thing that jumps is his paw and his, like, the shape of his head, maybe, or the orientation of his head. So when he reaches like that, that's this first frame. So it's like, boom. And then the next frame should be his 2 paws meeting, which they don't. Let's get... That looks just weird, though. It looks like a crab almost. It doesn't look... And it might be because... It's amazing how much difference 1 pixel makes. That looks so much closer to this second reference image. And then the next one, so if that's the first frame, boom, this is like this second frame where it reaches, and then the next has got to go. Hey, 7Arc, hey, thanks for the raid, bud. I appreciate it. We're doing some pixel art here. We're trying to get a gecko for our game. Hey, dude, how was your stream? Yeah, we got a chill stream on my end over here. We're just trying to some pixel art. We're trying to get a gecko walking for our game here, and it's not quite where we want it, but we are making progress. Okay, cool. Nice. Hey, yeah, welcome everyone. 7Arc's been helping me try to figure out some JavaScript for my WebSockets to get the chat integrated into my stream. A lot like he's got Bytefire going on. So I appreciate his help on all that, and I'm still, you know, I've got the WebSocket dumping the username into an HTML file. I've got that working. But I don't have, I don't like, and I've got where like active chatters, I'm keeping track of time for the active chatters, but I don't dynamically remove the names when they become inactive. So I just need to do some more work on that. This is looking close. I can't tell what. If this is his third frame here, let's see. So that's the second frame. Then he reaches with his left, and then that's when this next frame, his right feet need to come and meet. So I think if we meet right here. I appreciate the raid, man. That was really fun. I got raided for the first time yesterday, and it was just really fun. So it's one thing I really love about Twitch. I think it's really, really cool. Yes, that's looking closer, because his feet need to kind of match. Oh yes, that's looking close. So we've got that reaching. That looks really good. Let's see. That's actually really close. But the only thing is, this is a 16 by 16 sprite, which is the same size as our main character. Because our character is this big, so that would mean the gecko is about this big too. Which I guess I'm cool with, because I think it's cute and all, but and especially in the desert, so like down here is the desert. So the geckos, I think it'd be cool to have like the stationary gecko, and as soon as you get within like 2 frames from it, it'll start to animate and it'll run away from you or something. So that's kind of my vision for these geckos. I don't think they're not an enemy in the game or anything. But maybe I could show you guys some programming code if anyone's still here from 7Arc. We can take a look, and let me just minimize this stuff for now. Not that. Let's take a look at some of our code here, and we'll fix the problem that I just ran into, which was we can walk off screen off the left side here, which we don't want to do, and we need to. What else do we need to do? We need to stop updating our player upon a screen transition. So we kind of need to lock our player as is as soon as we've initiated that transition. So let's see if we can do that. We'll go, let's see. So we've got this listener function for an event to begin a transition in our scene. And it looks like this on transition stuff. And when that on transition happens, we become shifting. So what we can do is we can say, if we're shifting, we don't want to upgrade we don't want to update our main character. So, okay, AK Bob, I'll check out those dark brown pixels. Yeah, I'll check those out closer here. I'm gonna just switch back to programming for real quick. Let's do. So if we're shifting, we want to not update our player. So we only want to update our player if we're not self.shifting. And let's see if that, in fact, stops updating us when we walk. So let's see. Yeah, it looked, oh. Okay, now we're like stuck in an animation. It does stop us from updating, so that's good. I wonder if we turn on our debugging here, we can see what direction we're facing when that happens. Okay, so what's happening is it thinks that there's a last input because by the time our input was held, we stopped updating our table. So we just need to flush this input list if we finish shifting. So if we are finished shifting, let's go ahead and we'll say that our input list here gets flushed to an empty table. But there's another problem, which is we need to check for continuous input. We need to check for continuous input upon finishing shifting because we need to know what to repopulate this list with. So I think we can check if love.keyboard is down, whatever button is down, then we can go ahead and table.insert, and we need a list, which is our input list, and we need a value, which is going to be actually the string walk left, because that's what is actually triggering our animation. So we need to pass in the animation name into that list, but we need to do this for every direction. And we can do right, up, and down. So we've got walk down, walk up, and walk right. Now let's see if that might fix it. Okay, we aren't stuck in that animation anymore, and if we hold the direction, our last input is still correct. Okay, cool. So if I initiate that transition and hold up here, we don't flip up until we're done transitioning, and then we walk up. So looks like we've got that fixed. And very first thing we did in the episode was to floor our X and Y positions upon the end of the transition, which fixed. Yeah, man. Hey, feel free. I appreciate you hanging out, man. It's fun. Cool. So yeah, the first thing we did in the episode today was to floor our X and Y values upon a transition, and that fixed a blurry pixel issue. But we do still need to fix where we need to clamp our X position if we're walking left. And the thing is, our map is a 10 by 10 grid. So if we're in a column of 1, we shouldn't be able to walk left and initiate a transition. If we are in a row of 1, we shouldn't be able to walk up because there's no frame up here, or there's no scene up here to change. So we need to clamp our values there. So in our player update, wherever we do our X position assignments based on input, that's actually in the walk state, I believe. Player walk state, because now we're doing the whole entity system for our character. This is it. So what we can do is limit our X position. We don't want to willy-nilly assign our X position to be a negative walk speed if left is held down. We want to check if we're in a row of, actually in a column of 1. Yeah, we want to see if our map column is 1, and if so, we need to clamp our X position so that we can't walk past that screen. Now, we could just clamp it on every scene, because there is like a little bit of a buffer zone that you can kind of reside in before the scene transition starts. And actually, yeah, we don't actually have that right now. That was in our old code. We used to be able to go off screen a little further before the transition started, because that's how Link's Awakening plays it. So let's look at our begin transition code and see if we can't just build a little bit bigger of a buffer in there. So in our scene, we've got our change state for. We've got this begin shifting. So when do we begin? We want the event dispatch is what we're looking for, because this is listening for the event dispatched. So we can find an event dispatch here. It is in our player class. Okay, so here's where we're actually dispatching that transition, and we can say if the left side of us, so like this is a right scene transition, so if we're walking off to the right, we're seeing if, yeah, this is wrong. I think we want to do this plus our self.width. We want to check the right side of us to see if it's bigger than the right side of the screen minus a width minus that little bit of buffer. So let's see if that for our right transition lets us walk a little bit further. No, okay, so we did it the opposite direction. We need to see if our X position is greater than this edge buffer both. So maybe, yeah, if it's greater than a number, let's see what this edge buffer kavoth is. It's a 3 pixel buffer. Let's put it at 6, and we'll see if we can go a little bit further. Okay, not quite. We should be able to, and maybe I'm getting the number wrong. Maybe it needs to be smaller. Let's see. That's closer. We used to have this fixed before we changed our entity system, but I'm kind of curious why it's like the same code, but it's not working like it used to. So if our X is greater than this position, so if we want that position to be a little further to the right, let's just try not subtracting our self-width, and let's just see what that gives us. Okay. See, like we should be able to go off that screen, but we're not actually initiating the transition anymore. So let's stop subtracting this edge buffer and see what that gives us. It should be right when we're off screen. It'll translate it. Okay, well, we're not actually changing it. Okay, what is going on? Like, we only changed one thing. You would think it'd be easy to just shift this buffer zone a bit, but our X position is greater than. I really do think we want to check the right side of us for this, so I don't know why we had it like this. We want to check the right side of us and see if it's bigger than the virtual width minus the self.width minus the buffer, so I think that's right. That's just triggering it way too early. So what if we plus buffer. Let's see. Gosh, it really... I feel like I'm missing something here. Let's plus a 10 and let's see if we can... See, this isn't working as expected. That should be changing this. It doesn't look like it's changing that. And a right transition. I think that's right. Oh, and you know what? Let me see. The naming conventions might be different. No, I think that's right. I think we did name it according to that convention. I'm literally just gonna test. Oh, okay. We've got two values we're checking it against. That's why. We've got two values. So we had to add some extra logic because when we were translating our player position upon the scene transition, we're tweeting the values and we were accidentally detecting another transition event. So we kind of actually give a window. So we're saying if the left side of us is bigger than a certain side, and then the right side of us is smaller than virtual width. And I think we'd want to add the edge buffer here. Let's see if that gives us a little window. I really don't see it still. Yeah, we used to be able to get like our nose right up to it, right before we would initiate that transition. I really don't get it. It doesn't seem to change anything. When we change that value, it seems to... Actually, that looked a bit closer. See, we can get our nose really close before we get up there. What if we... And our edge buffer was 6, wasn't it? Oh, it was 3. So that's just like not using our edge buffer, which is fine. But we want it maybe one or two more pixels to the left. Let's see. It's okay. And then if we get this set, we can kind of globally say if to kind of limit his position to be the boundaries of any given scene, and then we don't have to worry about what row. Oh. And this screws with our idle animation now, looks like. Well, I can't replicate that bug. I don't know what happened there with his idle animation, but it's looking fine. Okay, so let's just add some general locking here in our player class. We'll go to where we're updating our X position, which is... I thought it was in our player class. I think it's in our walk state, actually. Okay, so let's limit this. If we're walking left, we want our left value to be locked by a math.max. So we'll clamp it at a math.max. And the two values we're giving, so math.max will give you the higher of two values. So we want to clamp it to 0 if this value would be negative. So let's see if that stops us from walking left, and it does. Now there is, yeah, so it'll allow us to get right up to the edge there. But let's make sure a left scene transition still works with that, because we're doing that on every scene. And yeah, it does work. It does look like it triggered it pretty early though. Yeah, oh. Yeah, the left, and you know what? That's the left transition we were modifying. That's why it didn't seem like it was changing anything, because we were changing the wrong one, I think. So that's in our player walk state. If we go back to our player class, this is, I think what I was calling right transition is the screen moving to the right, which would be walking to the left. So I think there was a miscommunication there. So if we plus, not a miscommunication, just a poor sight on my part to change it that. But then again, maybe not, because what we just changed there, that minus to a plus, stops our right transition from happening. Okay, so maybe our left scene transition is just jacked up, so. Bottom looks fine. I do like, yeah, left just feels really early, so let's just make sure we don't do that as early as we are. That would be in our dispatch, which is in our scene class. So we can go to the event dispatch for a left transition. Oh. And we're actually, okay, so yeah, we're limiting, we can't left transition if our column's 1, or if our column, we can't right transition if our column is our overworld map width, so that makes sense. But where's our dispatch? It's in our player class, not our scene class. Okay, so we'll go ahead and see if our left side of us is smaller than the self width, and this isn't right. we just want that smaller than the edge buffer, but even then, I want to say just smaller than 0. So if we go off screen even a tiny bit, and the right side of us is greater than self.width. Now this isn't right. We want the right side of us to be, we don't technically need to do this. It's just that when I didn't add this part, when we would move the scene, our X position would be tweened to the other side, and then when it would be moved to the other side, it would trigger a right transition because of its X position. So I kind of added in some more logic to prevent the dispatch from going unless our X position was in like a sliver of a side, not just our X was less than 0. That was like, let's see if that is still the case. If we just do left is 0, let's see. So as soon as our left side goes off screen, we should initiate that transition. And we can't because we clamped it, right? So if we go back and we just say, we go to our math.max and say -1 instead of 0, which is where? Math.max. It's all our old code. Oh lordy, we had so many. We refactored almost all that out with our entity class. And there's only 6, so it was in our walk state. There it is. So we'll replace this with a -1, and then we'll see if we get stuck in that transition how. Okay, we didn't. So maybe our tween value is different now, because we're actually not translating our player's location anymore. That's another change we just made. We're not translating, I mean, we are tweening the value, but it's not being translated by the scene shift transition. That's one change we made at the beginning of today's episode. We did right here. This is the translation once we're shifting. So if we're shifting, we translate it. But I put it in between a love.graphics and a love.pop, which makes us able to render the player outside of that translation. So I think that fixes our event dispatch problem. So now our event dispatch can be a lot cleaner. And is that in our player class? Let's see, dispatch. Yep. Okay, so we can have this a lot cleaner now. We don't have to do all this bullcrap. What we can do is say, if the right side of us, self.width, is greater than the virtual width. So just if we're off screen, if 1 pixel of us is to go off screen, we'd initiate that transition. Cool. Now I want to give us that edge buffer because Link's Awakening has that, where you can actually kind of chill right there. In Link's Awakening, you can chill about like right there before transitioning the scene change. So let's do the same thing with the left, which is close. Like we can get almost our nose off, but let's make sure. We'll just do a negative edge buffer here. And then for up, we're gonna check if the top of us is smaller than a negative edge buffer. And then down if the bottom of us, so a self.y plus a self.height. We can see if that is greater than the virtual height. And this is actually, since we've got the HUD at the bottom, we actually want to do screen height limit, I think I call it. Yeah, screen height limit. If the bottom of us is greater than that HUD Y location, then go ahead and initiate the down transition. So let's see. We should be able to, yeah, see how we're able to creep up on that bottom HUD, and then we can initiate. And in Link's Awakening, we actually render the character on top of the HUD, so we can do that real quick too. So AKA Bob, this has been, actually I don't know the date. I think it's been just over 2 weeks though, of working on this game. And we're about to have geckos in the game finally. Took long enough. So we do need to make sure that our clamping, okay, so this is the problem. We can't walk left because we're clamping our X position to be -1, but we don't trigger. We just need to make sure our clamping position is 1 pixel smaller than whatever that edge buffer is. So in our walk state, we can go find where we're clamping that, and instead of max 1, we can clamp it to, and we can't just put negative edge buffer. I think we have to, actually, what we can do is we can clamp it to exactly that, but then under our event dispatch, we just make sure there's an equal to under our comparison. So smaller than or equal to that value there. So if we're clamping our position here, we do want to clamp our right position as well. So our right position would be clamped at the lower of 2 values. So a math.min of our current location, or a virtual width plus that edge buffer. And then for up, we want to clamp our Y position to be the bigger of 2 values, so a math.max, and the 2 values are going to be its current Y position or a negative edge buffer right off the top of the screen there. And then for down, we want to clamp our position to the lower of 2 values. So it's going to be a math.min, and it's going to be our current position or the screen height limit plus our edge buffer. Now, the last thing we should also do is make sure that the dispatches here in our player class, yes, we want to make sure that these are or equal to. So if if we're on the frame that we clamp it to, go ahead and initiate that transition. But that actually doesn't allow us to stop the transition in the top left quadrant in our map 1-1. It will allow us to translate, or it will allow us to dispatch those transitions on every other frame other than the boundaries of our map. So we do still have to figure that out. It shouldn't be too hard. So let's see. Yeah, we're just making sure we can initiate those transitions, and we've got, oh, we're messing up our animation again. But only sometimes? I think player walk state. We must have 43 in player walk state. We're crashing. Let's see. Oh, math.max. We shouldn't get stuck in that walking animation. So I'm not sure what happened there. See? Well, oh, we didn't get stuck. That's weird. Our last direction is getting knitted to down. No, it isn't. I don't know why. Sometimes I feel like it gets... See, like I didn't press up by the time that finished transitioning. So I don't know why it changed. Oh, I think we need to... Okay, so if I'm holding, like, if I walk directly left and hold down as I initiate a left transition, but then let go of down, actually, it's like it's remembering what I'm pressing in the middle of the scene transition, and then it turns my body to face that way. Well, I can't get it reliably to do that, so we need to make sure we fix that. I think it's under a finished transition in our player state that we'd want to go and flush our table. We are setting our last input, but where is our finished shifting? Is this... Maybe it's in our walk state. We're looking for a finished shifting. Huh. I thought it was called finish shifting. Begin, yeah. Okay, it's in our scene class. Okay. So, oh, we do flush our input list, and then we populate it. Oh, maybe not is down, maybe it was pressed. No, we have to check for that. We have to check for that because otherwise it won't flush our list because we're not updating our character in a transition state. So if we turn that off, it'll get stuck in the walk animation. Actually, it didn't. Okay. And you know what? Maybe we just flush our direction, not our... We need to get our direction to be equal to the value of our last inputted. Okay. So what's tricky is our input list is a table of values called walk left, walk up, walk right. If it were just called left, right, up, or down, we can actually change our player's direction based on the last input. But last input, since we're not updating our character in the transition stage because we need to stop it from rendering, then our last input is whatever our last input was upon a begin transition, which is fine. But if we initiate a transition holding a last input, then we stop updating, and then if we let go of that, then as soon as we're on the new frame, on the new scene, it still thinks its last input is right, which means it'll still walk right even though you're not holding a button. So that's the issue I tried to get around here with flushing it manually. We flush it manually, and then we only populate the input list again with that direction if it's currently held down at the end of a transition. So if we hold it walking in and let go, we're not having that same error. So see, that's weird. We went to a down transition, down direction, even though we weren't holding any input. I'm not sure how to recreate that. Like there, we went to an up direction without holding any input. So it's almost like, yeah, is that the case? Let's look at any dot direction assignment we give. And I'm pretty sure we only do it in our walk state. And we only do it, yeah, we only want, we do it based on keyboard input while it's updating. But that would only get called if we're actually updating our character, which while we're transitioning, that doesn't happen. So I'm a little confused why he's doing that. If we turn that back on, does that fix that issue? He's still facing, he's facing like the last inputted direction that I walk upon starting a scene transition like that. So I'm gonna have to figure that out. I don't know if I'm gonna figure it out tonight because I've already tried what I thought would fix it. And we are clamping in that top left and bottom left, or top left and very top quadrant. So since we're in a map 1 of 2 right here, it's hard to see with the debugging on there, but anytime we're at any border of our 10x10 map, we shouldn't be able to initiate a transition. We should just clamp to those values. So if this is, I think in our scene, we're doing the rest of our debugging here. Yeah, let's turn this back off so you guys can see the map values. So map 1-1, we shouldn't be able to initiate a left transition walking anywhere here. And we aren't. And then if we get down to this next one, 5, and actually, yeah, it's 5x5, not 10x10. No, it is 10x10, shit. Yeah, we gave us 100 maps here, 100 scenes. But we should be able to not walk off the bottom. Oh. Okay, so maybe we did the clamping wrong for the screen height limit. Let's see if we can fix that, and then maybe we'll just call it night because I'm getting tired. Entity walk state for a. It's not entity walk state, it's player walk state, and we'll go clamp our down. We'll clamp our Y to become the smaller of 2 values, and it's a screen height limit. Let's try just screen height limit, and let's make sure, because we're checking, of the top of us would be the screen height limit, so we would want to subtract our height. So we would say subtract our height, self.height. And then we could add in our edge buffer. And did we spell that wrong? Oh, it's not a self.height, it's a self.player.height. And then what we can do is in our play state, we can just initialize us not at 1-1. Let's see. I think it's in our scene, actually. We used to initialize us at a certain scene, and I'm not seeing where we do that. Since we swapped over to our entity system, because we used to initialize our player with a scene to be populated, but now where's our scene declaration, or our scene instantiation rather? Right there. It's in our play state. Yeah, okay. So let's give us a row of 10. So we'll just put us at the 10th so we don't have to walk down there. We're at our 10th. Now we should not move off the bottom there. So maybe that buffer is too much. So maybe we just clamp it to just the very top there. I don't know. Okay, that makes sense. So now we can't walk off the bottom of our 10th frame, and we can't walk off the left. And then if we go to 1010 in our play state, we should not be able to walk off the right side either. And let's go to 1010 here. And now we're in 1010, and we should, oh God, okay, well, let's fix that. We want to make sure that our clamping is limiting us. So when right is held down, we're going to get the smaller of two values, and it's going to be the virtual width. See, we're doing the same thing here. We're not subtracting our self.player.width. And now we should be clamped. Nice. And we've got the buffer. And then we're clamped down here too. Cool. And then we could still do our transitions. So we fixed quite a bit today. We've got our character translations working appropriately. We've got our clamping to the scenes working for our global map tables. We fixed a blurry pixel upon a scene transition. We do still have a potential bug with our direction. Like there, I was able to mimic that bug, which is sometimes when you hold a direction, sometimes when the last input is a different direction than you initialize it, or initialize a transition, then by the time we finish a transition, he turns directions, which we don't want that to happen. We want to make sure that his direction is flushed to his last input upon a begin transition, and I think I might have just solved it, but we'll see if in our... We want to go to our dispatch, which is in our scene, I believe. Our event dispatch for a transition. And this is the event listener. I keep forgetting where the dispatch is. And it's in our player class. And how'd you get that Pikachu, aka Bob? Is that part of the default Twitch stuff? If you're still here. I know you got stuff to do. Okay. Yeah, I think we want to assign, before we assign our dispatch, we want to assign our direction to be the exact direction that gets dispatched here. So I think what we can do is, do we have reference to our player entity? I mean, we are our player entity, so we should be able to say that player.direction, self.direction, gets whatever direction is held here for the dispatch, and that should fix our bug, hopefully. Player.direction gets the actual string of this direction, and that should hopefully fix our bug, and then we can maybe export our gecko sprite and call it a night. Self.player.direction gets up and self. Oh, dude, that's sick. That's awesome. You got the Luchador Pika. gets down. Okay. Let's see. Okay, so player, it's not self.player, it's literally just self. I talked that through and then typed the wrong thing. Okay. Let's see. Okay. It's not behaving as I assumed, but it did fix, I mean, because the thing is, we can go left while facing down, if down was our last input. And what I thought we just did was to change our direction to be the direction of the dispatch we just did. And actually it does, it just doesn't change our animation. So I think that fixed the bug. Oh, I think I just saw the bug again. Let me see if I can recreate it. Oh, yeah. Oh, it's not right. It's not right. I don't know how to fix that just yet, so I'll leave that for tomorrow. We'll leave us a note saying, fix the direction of player upon multiple inputs on scene transition. Okay, so we gotta do that, but we did do a lot of good stuff today, and we've got the workings of our little gecko. I know AKA Bob said, what were you saying? You said take a couple pixels off, missing a couple brown pixels at his left neck when his left front foot is back. So we're missing a couple dark pixels at his left neck. Oh, like the gap right here? Like this? Is that what you're talking about? Like that? Maybe? Okay, cool. Yeah, and then maybe right there too. Oh, yeah, his shoulder gets really clunky up there. That's not quite it, but let's see. I think, shoot, I don't know. I feel like he should, well, that one maybe is too much. But when his arm's up, it should be there. Yeah, I think when his arm's up, it should be there, and when it's down, it should not be, so. Okay, well, let's see. Something like that? That is looking pretty good. There's like, it's looking pretty good. It's hard to, it's hard to say what could be better, because it all happens so fast. I think I'm happy with that. Let's just save this as an A-sprite. We'll save it as an A-sprite because I'm not going to export it just yet. We'll call it Gecko Walk in our A-sprite. Because we have to export each frame, so I just want to make sure that those are right before we export and import them. Because I know that'll take longer than I'm expecting, so we'll just hold off on it. And we'll just do a git commit here for the night. We did a bunch of stuff. We floored our X position upon a scene transition. We flushed our input list upon a scene transition. We pop our scene transition animation to render our player separate. We update our player only when we're shifting. We clamp our X and Y position according to the global map limits. And I'll put our scene back at 1-1 before we commit in our play state. And then we'll commit. So we'll go to play state. We'll go to the, what is it, scene. Right there. We'll just initialize at 1-1. So we're back here. And then we will git commit, call it a night. So we'll just say fixed player location upon scene transitions. That's about all I want to commit the message for. But thanks to whoever's here still. I appreciate everyone watching me stream. I'll be back tomorrow. And we'll probably be trying to implement the gecko into our entity system. So yeah, so AKA Bob, you think we go back to the bigger shoulders there? We'll be finalizing that tomorrow, so we'll sleep on it and we'll see how we like it, and then we can export and import them into the game tomorrow. But thanks for watching the stream. I'll be back. I'll catch you guys tomorrow.